All right, so here we have a question. It says, La Grande Roue de Montréal, the famous Ferris wheel in the Old Port, takes 80 minutes to complete 4 full turns. So it takes 80 minutes to complete 4 full turns. The passenger cabins reach a maximum height of 60 meters above the ground, and the lowest point where the passengers embark is 2 meters above the ground. So question 1 wants us to write a function in the form y equals a sine b x minus h plus k that represents the height of a cabin in meters as a function of time where x is measured in minutes and x equals 0 corresponds to the cabin being at its lowest point. So let's quickly draw a diagram here so we have a better idea of what's going on. So that's the floor. Let's say like this. That's the Ferris wheel. Okay, that's decent circle here. And we know that the maximum height, so up here, that's the maximum height, right? That distance from the top to the floor is 60 meters. And the distance from the lowest point to the floor, right? This distance right here, we know that that's 2 meters. So looking at this diagram real quick, you can probably tell that the distance from the top of the Ferris wheel down to the bottom of the Ferris wheel would be just 60, which is the distance from the ground to the top, minus 2, which is the distance from the ground to the minimum, right? So 60 minus 2, that's going to be 58 meters. And if you imagine now kind of cutting this Ferris wheel down the middle, right? Then the distance from the top to that midline or from the midline down to the bottom would just be 58 divided by 2, which is 29 meters both ways, right? And so now you can probably tell that the height of that midline here would just be 2 meters plus 29 meters, which gives me 31 meters. You could have also found the amplitude, which is the distance from the midline to the bottom or midline up to the top, by remembering the formula. Amplitude is equal to max minus min divided by 2, which gives you, in this case, 60 minus 2 over 2, which is 29 meters. And then you could have just added 29 to that 2 to get back to your 31, which we found before. Okay, so at this point, we can kind of start imagining what our sine function would look like. So let's just draw our axes here, right? And we've got x, we've got y, and we know that at x equals 0, our initial value is going to be when the cabin is at its lowest point, which is, we said, 2 meters, right? And then let's just draw another line here. Let's say that's 60 meters, just so that we have an idea of where we should kind of stop drawing our function, right? So we know that our sine function is starting at the bottom here. It's going to go up and maybe go back down. Maybe we'll draw another cycle like that just for fun. Okay? All right. So how long does it take for one cycle? Well, we know it takes 80 minutes to complete full 4 turns, right? So we're going to go 1, 2, 3, 4. That takes 80 minutes. So then for one cycle, just one turn, one ride around that Ferris wheel, right? Then that's just going to be, oh, that's what we're going to call our period, right? The length of time that it takes to go just fully around that Ferris wheel once. It's just going to be 80 divided by 4, which tells us that's going to be 20 minutes, right? But remember, our Ferris wheel ride starts at the bottom, and it should end when we're back at the bottom, right? So then one ride of the Ferris wheel is just this length right here, the distance from this lowest point to the next lowest point. And so that's just going to be 20, okay? Okay, so remember that the question is asking us to write a sine function that represents kind of this motion here, right? So what do we know so far, right? We know that the sine function can't really start at this bottom point. It has to start kind of at the midline, right? Which we said was 31. We got that from over here. So let's just draw that line real quick and see what's a possible starting point. Let's say, let's start right here, right? So let's say that's my starting point. And my cycle is going to look like this, okay? Great. So remember, k, right, this k here, my sine function, represents the height of that midline. So we already have k. K is going to be 31, all right? And if we're going to start here and go up, then back down, then that means that my a and my b have the same sign. So let's just make them both positive in this case. That tells me that my a, okay, which is just going to be now corresponding to the amplitude, is going to be 29. So we have that as well, okay? B, okay, is just going to be 2 pi over the period, and we found the period, which was 20 minutes, so 2 pi over 20, that's just going to be pi over 10. So we have the b value as well. All we're missing is the h value, which is the x coordinate of that starting point. So I want to figure out when it is that I'm going to be at 31 meters of height, right? So let's imagine for a moment that we've got a guy here, right? And he's riding the Ferris wheel, okay? So he's going to start at the very bottom here, which is at 2 meters in height, which is why my initial value here on this graph is 2 meters, right? And we know from the period, which is the length of one cycle, that's going to take 20 minutes to do one cycle or one ride around this Ferris wheel, right? Now you can imagine halfway through, so 10 minutes in, where would you be? You'd be halfway through this ride. You'd be up here at your maximum height, right? So on your graph, what would that look like? Well, you'd be at your maximum height up there. That's going to be 10 minutes in, right? Halfway through. Okay? So 10 minutes, we're up here. Now you can further deduce then that half of half, or half of 10, right? Or you can even say a quarter, right? Well, where would you be? Well, half of half, this is half, then half of half, you'd be over here, right? At 31 meters in height, right? Which is your midline. You're halfway up to your maximum, from your lowest to your max, right? You're halfway through. And on your graph, what does that correspond to? Well, that's half of half right here, 5 minutes. You're actually exactly right here. Like we see on this diagram, you're at 31 meters in height. You're at that midline, right? And so, like we said before, right here is a starting point for one of our sine or cycles of sine, right? And so we can say that h, one of our possible h's, is 5 minutes in, okay? And so now we have all the ingredients we need to write a rule for my equation, for my sine equation, right? We could say y is equal to a, we said that was 29, okay? We have sine, b, we said that was pi over 10, and we've got x minus 5 plus 31. And that's going to be the rule for question 1. Now, question 2 is asking, at what times during your experience you would attain a height of 45.5 meters, assuming you stay on for 2 cycles. So 45.5, that's around like here, right? It's above your midline. So let's, for example, once again, picture we're this guy, and we're starting down here, and we ride up here, and we reach that height, okay? But we're staying on for 2 cycles, so we have to keep going, and then we hit that height again, so there's a second solution here. We finish our first cycle, we go again, and we hit that height again, so that's a third solution, and then we've got a fourth solution here, and then we finish that second cycle. So we're looking for 4 solutions in total, okay? Now, I'm going to need a little bit more room to work with, so I'm going to kind of erase some of this stuff here, okay? And I'll just rewrite my final answer for question 1. So y equals 29 sine pi over 10, x minus 5 plus 31, okay? Now remember, we're looking for a height of 45.5, and that height corresponds to this y, okay? So we're not just plugging in x equals 45.5, x is time, right? Measured in minutes. So 45.5 is that y value, okay? But before we even get to solving, okay, since this is quite a long equation, we can kind of replace this bit here with a theta, okay? So now we can solve. We have 45.5 is equal to 29 sine theta plus 31, and we're going to isolate for that sine theta. So let's subtract both sides by 31 here. We're going to get 14.5 is equal to 29 sine theta. And then we divide both sides by 29, so 14.5 over 29 is equal to sine theta. But this simplifies nicely. That's just a half, right? And here we don't even need our calculators. We can just look at a unit circle. You're going to see that my first theta is pi over 6, and the second theta is 5 pi over 6, okay? But now we're not looking for thetas, we're looking for x's, right? We're looking for time, okay? So we can just write my theta 1 up here, right? We know that was pi over 6, and we'll make it equal to this bit right here, pi over 10x minus 5. Okay? And so now if we divide both sides by pi over 10, right, because we're solving for x, you're going to get, what, 10 over 6 is equal to x minus 5. And then we add 5 to both sides. You're going to get that x is 6.66 repeating. Okay? And so now we're going to look for my theta 2 here, right? We know that's 5 pi over 6. And we know theta, once again, was that thing there. So pi over 10 x minus 5. And we're going to solve for my x. So divide both sides by pi over 10. You're going to get 50 over 6 is equal to x minus 5. And then if you add 5 to both sides, you're going to get x is equal to 13.33 repeating. So those are my two solutions during my first kind of ride around the Ferris wheel, right? But we're staying on for 2 cycles, right? So like we said before, we're looking for 4 solutions. So how do we get the third and fourth solutions? Well, we know the period was 20 minutes, so we just have to add on 20 to this and 20 to this to get my third and fourth solutions. So if this is x1, this is x2, then x3 is just x1 plus 20, and that's going to give you 26.66 minutes. And my x4 is just going to be x2 plus 20, and that's going to be 33.33. Okay, and here we have our 4 solutions.